try question. Prove that mod z1 plus z2 square is equal to mod z1 square plus mod z2 square if and only if z1 upon z2 is purely imaginary. Okay, you first expand z1 plus z2 square. In fact, we have result, that is mod z1 square plus mod z2 square plus z1 z2 conjugate plus z1 conjugate z2 is equal to mod z1 square plus mod z2 square. Now this gets cancelled out from both sides. So we have z1 z2 conjugate plus z1 conjugate z2 is equal to 0. Now we have to prove that this is purely imaginary. In fact, when any complex number is purely imaginary, its real part is 0. But here we have conjugates involved. तो आप बता सकते हैं कोई प्रॉपर्टी जब कोई भी कॉम्प्लेक्स नंबर प्योरली इमेजिनरी होगा तो कॉन्जुगेट के फॉर्म में उसका रिलेशन क्या होगा? If z is purely imaginary, then we have z plus z bar is equal to 0. That means if we have to prove that this is purely imaginary, then z1 upon z2 plus conjugate of z1 upon z2 will be 0. That is z1 upon z2 plus z1 conjugate upon z2 conjugate is 0. That means z1 z2 conjugate plus z1 conjugate z2 is 0 after taking LCM. So from this, to get this result, divide both sides by z2 conjugate. So we have z1 upon z2 plus z1 conjugate by z2 conjugate is equal to 0. That means this complex number is purely imaginary because sum of this and its conjugate is 0. Further, we can have when this complex number is purely imaginary, then argument of z1 upon z2 is either plus pi by 2 or minus pi by 2. That is argument of z1 minus argument of z2 is equal to plus minus pi by 2.